Hello everybody, this is Rudra Pradhan here. Welcome to BMD lecture series. Today we will continue with prescriptive analytics and that too coverage is on integer programming. So, we have discussed several problems in the prescriptive analytics. Here the main idea is to get the values of the decision variables to address a particular business problems and come with a kind of management decision as per the particular business requirement. The thing is that we have discussed several problems starting with linear programming, primal structure, dual structure, then there are various methods through which you can solve a problem and then come with a kind of optimal solution, that is the values of the decision variable through which we can address the business problem as per the particular management requirement. So, the whole idea is we have a kind of business business problem and the process what we are doing here in the case of prescriptive analytics, that having the kind of informations and the kind of particular problems, we transfer the particular problem to a mathematical models, maybe in a linear programming format or in a kind of nonlinear programming format. So, the whole idea is we have to first transfer the particular problem into model format, then through a particular technique we like to optimize the particular structures and then look for the optimal solutions where the values of the decision variables can give you some kind of strategic decision to a business process. So, that is how we are discussing various structure of mathematical modeling and that too under the prescriptive analytics to address the business problems and come with a kind of decision through which the business problem can be addressed in a more effective way or in a kind of more efficient way. And in the last couple of lectures we have solved several problems starting with simple structure to complex structures. I mean we start with bivariate structure to multivariate structure where the objective function may be with respect to two variables or more than two variables and then corresponding constants are maybe 2 or more than 2. So, the simplest structure to start with the game, the prescriptive analytic structure, that too the optimality structure. So, we must have at least 2 variables and then we must have a 2 constant, means the problem which we are discussing, and then depending upon the problem. So, it may have a more number of variables and more number of constraints. Then we like to actually optimize the particular process, for instance optimizing the resource allocation to get maximum profit or the kind of minimizing cost, something like that. So, so once you understand the problem, so we like to develop a kind of structure through which the entire problem can be transferred into a mathematical model. Then we look for the kind of solutions and that is with respect to some of the techniques what we have already discussed, like graphical structure and then primal simplex method, dual simplex methods. So, depending upon the particular problems we can apply a particular technique and look for the kind of solution. So, after knowing the linear programming structure, the kind of model formulation, several kind of techniques to work out the particular business problems. Again we have already discussed the sensitivity concept where after getting the optimal solution we can bring some kind of alternative options with respect to some of the changes, that with the coefficients of the objective functions, then the coefficient of the constraints and the addition and subtraction of the particular constraints, and then we can add more variables. So, there are many different ways we can apply the sensitivity structures to the optimality solution, and then again we can have a more kind of flexible options to address the business problem and to come with a kind of management decisions. Now, taking the clue over the linear programming problem, that to primal structure, dual structure, primal simplex, dual simplex, then sensitivity structures. So, now we are going to address two more problems in the prescriptive analytics, that is the integer programming and the kind of goal programming. Then after that we will move to a particular structure called as a nonlinear programming. So, corresponding to primal structure and dual structure, so integer programming, goal programming are not completely different. They are they are the kind of tools analytics where the particular problem must have objective functions, must have constants, must have conditions, and then look for the kind of solution. And in the case of integer programming, so the typical structure is more or less same, like the problem which we have solved in the case of primal problem, and we have solved in the case of dual problem. And what is more important here, that once you understand the problem and transfer the model, transfer the problem into model and look for the optimal solution, then one extra things we are supposed to check there is whether the values of the decision variable are integer type or not. If the values of the decision variables are coming integer type, that means the particular optimal solution is is a perfect kind of structure through which you can address the business problem. And there is a high chance that after solving the problems you may reach optimality, and we may get actually values of the decision variable through which you can address the problem. But sometimes some of the business problem in such a way that your values of the decision variable must be by default integer type, otherwise you cannot actually address the problem more effectively, and you cannot actually streamline the process as per the particular requirement. For instance, let us say there is a kind of production process, and there are two decision variables, say x 1 and x 2, and x 1 leads to let us say production of chairs, and x 2 may be the production of tables, and then there is a objective function to optimize the profit function subject to certain constants, maybe manufacturing constant, maybe labor constants, maybe infrastructure constants, and after doing the kind of process we will get the optimal solution. That means, typically this kind of problems, the whole idea is what should be the number of chairs productions and tables production, so that the firm can achieve highest profit. So, now while calculating all this or fixing a kind of problem like this, so we must have actually the values of the decision variable kind of integer type, otherwise we cannot actually get the optimal structure perfectly, so that we can address the business problem as per the particular requirement. For instance, let us say x 1 optimal in the optimal solution, x 1 is coming let us say 3.5 and x 2 is coming 4.5. So, that means tables cannot be 3 and half, and chairs cannot be 4 and a half. That means, so if I am saying that chairs are 3 or tables are 4, that means it is completed. So, the process is completed, and it is ultimately final product, and that too available for the market or available for the customers. So, now the moment you will say 3.5 or 4.5, that means, so it is a half product, and a chair half product and table half product is a kind of meaningless concept to address the business problem so far as optimality is concerned. So, likewise we have a couple of business problems where our optimal solution should be integer types. That means, in this kind of scenario business problem, so our objective is not to get the optimal solution or the values of the decision variable. We have another kind of condition or restriction where the values of the decision variables something like integer type. So, that means, after getting the optimal solution, next step is to check whether the values of the decision variable are integer type or not. If in case we are getting the values of the decision variable integer type in the optimal stage, then we can stop there and address the problem. So, there is no role of the typical integer programming. So, now if in case a particular variable or all variables or few variables are not integer type, then this is a complicated kind of issue, and that too the method will show you that we have reached the optimal solution, but actually it will not practically true or so far as a practical requirement is concerned. So, this cannot be considered as a optimal solution to address the problem or business problem. So, so again, so there is a next level entry, again you have to restructure the problem and redesign this typical structure, that is the iterative process through which actually we look for some kind of another optimal solutions where the values of the decision variable will be integer type. So, that means it is a two stage process. First having the particular problem, business problems with objective function, constraints and condition, we first look for the optimal solution and then check the values of the decision variable whether they are integer type or not. If they are not integer type, then that means technically so we have not reached the optimal solution, even the method is showing that we have reached the optimality. So, so this is something called as extra kind of condition or extra kind of constraint through which the optimality structure will change little bit. Obviously it cannot be in the case of in the type of ratio, but it will be the kind of integer types. Okay, so that is how the kind of structure. So, that means technically, so we like to know how is the kind of integer programming gap and what are the areas or what are the business problem, it is strictly the kind of requirement, and depending upon the kind of requirement we look for the optimal solution where the values of the decision variable will be integer type. So, that means now we like to see whether the methods which we have discussed like primal simplex, dual simplex, they are in a position to give you the values of the decision variable at the optimal stage which are integer type. If not, then what are the procedure through which the particular optimal solution again will give you another kind of optimal solution where the values of the decision variable will be integer type. So, more or less it is a kind of sensitivity structure. So, that means after getting the optimal solution we are putting another kind of restriction through which we will reevaluate the problem depending upon our requirement, and then check whether we have reached the optimal solutions and the particular optimal solution will be fulfill our target or the kind of requirement, that is the management requirement. So, so obviously we like to know few things here regarding the integer programming, goal programming and something like nonlinear programming. So, this is the coverage of this particular unit. So, let us start with the objective of this unit, and then we will go by the kind of requirement of integer programming. And so, the whole idea about this unit is to know the integer programming problems, which I have already already highlighted slightly, to know the kind of requirement, know the kind of situation where it is very useful, and that to in the kind that is that to actually to find out the kind of situation where management decision can be effective, that more effective, in fact you can say. So, now knowing how integer programming problems differ from general linear programming problem, and in the case of integer programming, so we can have a three different structure. So, one is called as pure integer programming, then the second one is called as mixed integer programming, and then 0-1 integer programming, like binary kind of structure, the way we have discussed in the case of predictive analytics, where we have linear probability model or binary choice models where the values of the decision variable will be 0-1 only. So, that means here in the case of integer programming, so typical structure will be three types: pure integers where all the values of the variables are integer type, and the second one is the mixed integers where some are integer type, some are non-integer, and then again 0-1 integer programming, that means the values of the decision variable will be only 0-1. So, in that case how we have to address the business problem and what should be the kind of optimal kind of solution. So, in fact depending upon a particular business problems, so these three kind of integer programming problems can be more effective and can address the problem business problem efficiently. And we like to know how Excel or solver package can help to get the integer programming solution. And then we like to formulate specialized integer programming problems like set covering, fixed charge, facility location problems, and like that we have a couple of business problem in real life scenario. And so far as a solution to this particular integer programming is concerned, so it is not something different. It is a simple kind of linear programming structures like primal structure and dual structure. As usual normal process, we start and reach the optimality and then get the values of the decision variable, and the additional check after reaching the optimality to see whether the values of the decision variable are integer type or not. If not, then again there are some methods again we can apply through which you can get the values of the decision variable that will be the integer type. So, there are two standard mechanisms to solve the problems and then look for the optimal solution or the values of the decision variable where they are integer type. So, the first mechanism is called as a CPM, that is cutting plane methods, and the second mechanism is called as BBM, that is branch and bound methods. And these two methods are very useful to address the particular problems and then look for the optimal solution which is actually the integer type. So, that means typically in the integer programming problems, so we simultaneously like to use both primal simplex structure and dual simplex structure. So, in the first part of the particular process is in the form of primal simplex structures, where we simply solve the problems and try to reach the optimality, and once we reach the optimality, then we will check whether we have a feasible solutions, and if we have a feasible solution, what is the values of the decision variables. So, now if the values of the decision variables are integer type, then we can stop there and no point to go to the second step where we can use cutting plane method or BBM, that is branch and bound method. But if at least one of the particular decision variable is not actually integer type, then we can look for further kind of processing, that too through cutting plane methods and branch and bound method, where we can get some kind of further solution or some kind of change structure through which we can again have the optimal solution, and the values of the decision variable will be typically integer type. And in fact, there is no much deviations from the original optimal solution, where there is there is a question of integer type, and again there is another optimal solution where the fulfillment of integer type solutions. So, for instance, let us say a particular variable say 3.5. So, that means typically it will give you the kind of signal that so the values of the decision variable will be either 3 or something like 4. So, typically not exactly with that particular variable, it may also less or more, because it is simultaneously connected or integrated with the other variables, and that too with different constraints and the kind of conditions. But the particular value is not actually useful for the the particular business requirement. So, that is how we are looking for the alternative solutions, and we will reach the optimal solution, and that too the values of the decision variable will be integer type. So, we like to know the method to solve 0-1 integer programming and describe the type of problems again that goal programming is designed to handle. And again we like to check the similarity between goal programming and linear programming, and we like to know the formulation of goal programming models, and again we like to know the structure of how to solve the goal programming models and how to interpret the solution of the goal programming model. So, that means typically in this unit, so we like to touch upon first the integer programming. So, now after knowing the integer programming, then we move to a concept called as goal program. This is a kind of multi objective kind of concept. Till now whatever we have discussed is a single objective with more number of constraints and more number of variables, but there are certain business problems where we have a multiple objectives with number of constants and conditions and number of variables, where we are looking for the optimal solution and then looking for the values of the decision variable, where we can actually simultaneously take care all the objectives together. So, ultimately again we like to discuss some of the concept like nonlinear programming, and again under the nonlinear programming with a single objective, multiple objectives, single constraints, multiple constraints. So, that means we have a different kind of structures depending upon the business problems. So, we like to check which particular model will be fitted to a business problem and then address the particular problems as per the particular requirement. And in fact we like to know various mechanisms through which you can solve also nonlinear programming with a single constraint, multiple constraint, with one variables, multiple variables. So, depending upon the objective and the kind of a business requirement, but ultimately in the case of nonlinear programming, so it is the game between objective function and constants, and somewhere so there is a nonlinearity features, and in that context how we have to address the business problems and come with a kind of solution where we can address the, or we can take the management decision more effectively. So, these are the following highlights which we like to address for this integer programming, goal programming, and the kind of nonlinear programming. So, technically three things we are supposed to address in this unit. So, the first one is the integer programming, the second one is the goal programming, and the third one is the nonlinear programming. So, now depending upon the particular requirement, so we start with the first integer programming. So, what I have already mentioned, it is a question of pure integer, it is a question of mixed integer, and it is the question of 0 1 integer programming. So, in the case of pure integers, all the decision variables should be integer type, and in the mixed integers the requirement is a integer type, not for all variables. For instance, say labor is a one kind of decision variables, and then the table is a kind of another decision variables. So, now 1.2 labor can be can be meaningful, but 1.2 table is not meaningful. So, that means 1.2 labor means say, so the kind of one labor, and then he can work for half days. So, one labor means there is a kind of it depends upon how many hours he or she will work in a particular assignment. So, let us say 80 hours, then so the moment we will say 1.5 labor or 1.2 labor. So, depending upon the kind of situation, so we like to see how many hours ultimately he will work. So, this will be this will be more effective way to represent the situation, and then in this context, in the labor case, so there is no there is no typical requirement of integer type solution, but in the case of table, there is a typical requirement of integer type solution. Otherwise, we cannot actually come with a kind of optimal decision, and that too effective decision through which you can address the business problem more accurately. And then finally, the 0 1 integer programming. So, the requirement is integer variables to have value 0, either 0 or 1, or sometimes like the kind of situation a yes no type kind of situation, or the kind of binary kind of situation. So, so this is for the structuring, and let us start with a simple kind of game here, and this is as usual actually linear programming problems. So, let us start with the kind of concept here. So, here, so this is a objective functions, and the objective function is the maximization type and subject to certain constant here, and that is actually less than type, and as usual. So, we look for this optimal solution, and this is how the graphical structure. So, we have actually constraints, and then we are applying the constraints, then we look for the optimal solution. Since it is a less than type, so obviously the feasible zone will be this side, and obviously these are the corner point through which actually the optimal solution will be lying. So, there is high chance that in this case it is a 0 0, but in this case this is x 1 is having some value, x 2 is 0. In this case x 2 is having value and x 1 is 0, but here both x 1 and x 2 are there, and here both x 1 and x 2 are there. So, now there is a high chance that these values in this kind of line or in these points, corner points, may not have actually integer type. If it is integer type, then we can stop, or if not integer type, then again we have to diversify the particular structure. So, that means corresponding to a particular problem, we first look for the optimal solution. If we without any kind of extra efforts, if we are getting the optimal solution which are integer type, we can stop there. If not, then we have to add another restriction, or for integer programming we can actually redesign the structure, the optimal structure, by putting additional constant or the kind of restructuring, through which again we again go for the kind of iterative process and then look for the optimal solution. So, that means it is the combination of the particular process, the combination of what we have already discussed, like primal structure, then simple the application of primal simplex mechanism, then the kind of dual simplex mechanism. So, initially we start with the the particular problem, then look for the optimal solution up to optimal solution in the first stage. So, it is a kind of a primal simplex structure, and then since our requirement is the integer type of solution. So, then we are checking the kind of integer type solution. If it is the case of integer solution, we will have actually final optimal solution, and that to know further requirements, further processing is required. And in fact, if it is not integer type, then we will add something additional constant, or restructuring the problem, then again look for the optimal solution. So, that means it is a kind of 3 stage process altogether. So, primal, then look for the primal solution and check the optimality, and check the integer type, whether the values of the variables, decision variables are integer type. If it is the case, then we look for the a kind of optimal solution. So, that means here x 1 and x 2 is a kind of greater than positive signals, that is the condition, and against there is the integer type of signal. So, now depending upon the particular requirement, so we will look for the optimal solution, and then if not integer type. So, what I have mentioned that we have to create a new constant depending upon the optimal solution, existing optimal solution, and then reevaluate the particular process, and the reevaluate of the particular process depends upon the second stage kind of requirement, where we will use dual simplex mechanism, through which you can address the business problem, and then look the kind of optimal solution which is actually integer type. So, that is how the procedure through which actually you move, and we like to see how is the kind of structure. So, in this case, so this is what the kind of requirement. So, another case, this is some kind of big problem. So, as usual actually a business issue. So, now the entire business issue will be transferred into a kind of model. So, here a speed bot and the kind of type of another bot that is called as x 2. So, that means it is the game of 2 variables. So, it is 2 different bots x, and they are represented as x 1 and x 2, and since it is a kind of bot, so obviously the values of the decision variable should be on numbers, and that to exclusively integer types, like 10, 20, 30, 40 like this. So, it cannot be 10.5, 10.2 like that. So, obviously these are all constants, and having all these kind of structure. So, the first and the requirement is the transfer the problem into model, and this is what the model. So, so x 1 and x 2 will be the decision variable, and the objective function will be 40,000 x1s and 30,000 x2. So, that means the particular business requirement is to set profit of 40,000 for x1 productions and 30,000 for x2 productions, and subject to available constants, that is the labor weeks constants, and then the kind of the other raw material constants, that is 10 x that is 10 x1 plus 3 x2 less than 30, and 600 plus 1000 x2 less than 3000, again 500 x1 plus 200 x2 less than 1800. So, that means having the kind of structures, then we look for the optimal solution, and then obviously by default here the requirement is the non-negativity constant, or the kind of values of the decision variable which should be positive in nature. Obviously, it is a kind of production process, and x1 cannot be negative and x2 cannot be negative. So, by default x1 will be positive and x2 will be positive, either x1 positive or 0 or x2 positive or 0. So, now with the requirement of business, or to address the business problem more effectively, so the values of the decision variable should be integer type. So, now if we do not fix the integer type of target, then obviously it can be a 0 or some positive value, and that positive value may not be necessarily integer, that can be the ratio type situation. But here with respect to the kind of problem, so we are bound to have a solution, optimal solution, where the values of the decision variable should be integer type. Otherwise, we are not in a position to address the business problem more effectively, and cannot come in a situation to get the effective management decision. This is the solution through solver package. So, fixing the target and then look for the kind of optimal solutions. So, then for that we can go to the objective functions and then the constants, and then look for the optimal solution. So, the solvers, if you go to the solver, so the first hand requirement is to put the inputs and then setting the kind of requirement. So, that means technically, so here so this is the objective function indications, and then this is the objective function objective function structure, that is actually maximizing z equal to Cx, that means C1 x1 C2 x2. So, since it is actually two variable case, so obviously, so it will be only two different combination, and then we have a constant. So, they put the constant and look for the kind of solution. So, now if there is no integer kind of specification, then you just add the constants and then ask the solver to give the solution. So, obviously, corresponding to the objective function and the constants. So, solver will give you the optimal solutions, which may not necessarily the integer type, but after getting the optimal solutions, so we will check whether the values are integer type. If not, then you will put the integer type restriction. But by the way, in the initial process, if you have already set up the mind, or as per the business requirement, if you need actually integer type of solution, then you can actually set in the first levels the integer another constant, which will be the integer type. Then by default, so the software will actually process the kind of problem by more number of iterations, and then come with a kind of solution which will be having again optimal, and the values of the decision variable will be a type of integer type only. So, means the kind of integer type. So, as a result, so we can actually address the business problem effectively, and then then we will come with a kind of solution through which you can take the strategic decisions. So, this is how the solver results. So, we will take this problem, and then we will see how in the solver package the actual optimal solution and the kind of integer take and the kind of integer type of solutions. That means, when we look for the integer type of solutions, we like to have some kind of compromise. So, that means, the original optimal value of the j means objective function, and again where the values of the decision variable is integer type, the second optimal structures, then you will find the typical difference. Here the value of the objective function in the original framework will be definitely higher compared to the integer type of solution, where the value of the z will be little bit lower, because we are putting additional restriction that to integer type of ratio. So, as a result, while allocating the resource, some compromise we have to do. As a result, some productions have to be interchanged. So, that means with a given optimal structure, so maybe somewhere it will be cut and somewhere it will be added. So, then finally, we have a kind of an optimal solution where the values of the decision variable will be integer, and then we can address the business problem effectively. So, with this we will stop here, and thank you very much.